Hello geometry students, we're here in section 7-3, similar triangles. And then what we learned back in 4-4, we use AAS and SSS and SAS congruence theorems to prove triangles congruent. Now what we're going to do is we're going to identify similar triangles using the AA similarity postulate and the SSS and SAS similarity theorems. And we're also going to use similar triangles to solve problems. So, in the next slide, we have the angle-angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Alright? So if the two angles here are congruent, then we know that the third angle must be congruent also. So we only need two angles to be congruent to make the two triangles similar. Now, when we say similar, we don't mean congruent, we mean similar. Because remember, there is also a scale factor that could be involved. So we have triangle, if A is congruent to angle F, and angle B is congruent to angle G, then the two triangles ABC and FGH are similar. Okay, so we're going to determine whether the triangles are similar in the next example. So we have determined whether the triangles are similar, and if so, write a similarity statement. So we have 42 and 58 degrees, and we also have 80 degrees. Now, the fact that 58 plus 42 is 100 would mean that this angle here must be 80 degrees. So the question is, are these corresponding angles? So 42 is 42. Then we have angle E being congruent to angle A. And that's all we need. Let's see how they explain it. Okay, we have angle B equal angle D. Therefore, angle B is congruent to angle D. Triangle sum 180. So measurement angle A is 80. Now we have angle A being congruent to angle E because the measurement of angle E is 80. Therefore, they are similar by the AA similarity postulate. Okay. Determine whether triangles are similar. If so, write a similarity statement. Okay, so we know that vertical angles are congruent. So we have that this angle here in triangle QXP and this angle here in MXN are congruent because they're vertical angles. Now the question is, can we get at least one more angle inside these triangles that are congruent? And we know that we have then these symbols here represent that MN and QP are parallel. Therefore, QN is a transversal. So think about this angle here and this angle here, and what do they have in common? Okay, in terms of transversal and parallel lines. So if you're thinking alternate interior angles, I think you're on the right path. Therefore, if we have two angles, therefore then the two triangles are similar. So here we go. We have a vertical angles theorem, and then we have parallel. Since so angle Q and angle N, let's go back. Angle Q and angle N, just like we had marked out. So we have two angles in each triangle, right, being congruent. Therefore, the AA similarity postulate. Okay, let's check your progress. Go ahead and pause the video and determine whether the triangles are similar. Good. If you have triangle ABC is similar to GFH. Okay, and this looks like the exact example as before. Okay, check your progress again. Determine whether the triangles are similar. And you are correct. We have vertical angles. We also have the alternate interior again. Okay, we also have theorems. We have the side-side-side similarity theorem and the side-angle-side similarity theorem. So in the side-side-side similarity theorem, we have if corresponding side lengths of two triangles are proportional, then the triangles are similar. Example. If we have the JK and the MP, right, if that ratio between those two sides is equal to the ratio of the KL and the QP sides, which is also equal to the final LJ divided by the QM side, then the two triangles are similar. We also have side-angle side similarity. If we have the side RS, and when compared to XY, let me have it, whoops, so RS here compared to XY, if we divide that, and that equals the ST length divided by the YZ length, if those are the same, and if angle S is congruent to angle Y, this is called the side-angle side similarity. So then the two triangles are similar. They also could be congruent, but there's no guarantee. And here's the proof of theorem 7.2. Okay, you can pause the video if you like and kind of go through this, but you will not have to perform this proof. Okay, we're going to use the side in the side-angle side similarity theorems. We're going to determine whether the triangles are similar. If so, we're going to write a similarity statement, and we're explaining our reasoning. Now, we can probably easily see that AB, right, we're going to divide that by the DE, or vice versa. But let's do that. We're going to have 9 divided by 6. And that's going to be my AB divided by DE. Then what we're going to do is reduce that down. And reduce that down by division of 3, and we get 3 over 2. All right, so now we're going to compare that to the AC side, which is our 6. And we're going to compare that to the CD side, because that's the corresponding side, and that's a 4. And that also reduces down to 3 over 2. So it looks like we're using two sides so far. We're also going to then do the 7.5 side. That'd be the BC compared to the CE. 7.5 divided by 5. And that also reduces down to 3 over 2. So in each case, we have the same ratio of the sides. Therefore, by the SSS similarity theorem, then these two triangles are similar. Now, we could also have compared the 6 and the 4 and the 7.5 and the 5, and then we could have used the fact that this is a side-angle side to also prove it. So we go 3 halves all the way across. Therefore, by side similarity theorem. Okay, the next problem we're going to determine whether the triangles are similar, and if so, write a similarity statement. So we have, by the reflexive property, I think we can all see that angle M is going to be congruent to angle M. And if we're trying to see here is we have the small triangle on top and the big triangle, but they do share, right, that common angle M. So we're going to use the reflexive property, you know, for to show that they have the same angle. Okay, and then we're gonna have our side, and our side is going to be the MP side. So when I say MP, we're talking about this length right here, right? And we're going to compare that to the MS all the way down. So we have side length here compared to its corresponding length that goes all the way down. So that would be 12 divided by 30. Okay, and that would be then what we're looking for to reduce. And 12 divided by 30 does reduce down to 2/5. Okay, now what we're going to do is, so we have a side and an angle, and then we can compare the other side. And that'd be the MN side, right, length, compared to the MR length. So we're going to compare the 10 to the 25. So 10 divided by 25, we're going to reduce the bottom and top by 5, and again we get 2/5. So we have two side lengths in proportion, and we have the angle in between them. So in this case, we're using the side-angle side similarity theorem. Okay. Check your progress. Go ahead and pause your video to determine, okay, if the two triangles are similar. If you said B, you were right by SAS. So we can compare the we want to compare the 2 to the 6. We can do that, 2 to the 6. We also can compare the 4 to the 12. And in both cases, they both reduce down to 1/3. We also could have compared 6 to 2 like this and 12 to 4, and we could have said they both reduce down to 3 to 1. Okay, so we have two sides, and we also have the vertical angle in between. Therefore, we have it by the SAS similarity theorem. All right, let's look at this example. If RST triangle and triangle XYZ are two triangles such that RS compared to XY equals 2/3. So what we're doing there is we're doing a ratio of one of the sides is a 2 to 3 ratio, and then we'd like to know that which of the following would be sufficient to prove that the triangles are similar. Okay, so maybe just drawing the triangles out. Just draw two triangles. And they could be the same size, doesn't matter, but we're just going to draw them so they kind of look like each other. Right? And we're going to have R, S, and T. Okay, we're also going to have the X, Y, and Z. We've got to make sure we put them in the same order, like this, X, Y, and Z. And then what we just said was the RS side, so this side, right, compared to this side, is in a 2 to 3 ratio. So it says, what else do we need, right, in order to show that they are two triangles are similar? Okay, we would need to show that RS over XY equals RT over XZ, right, which equals the ST over YZ. So it looks like we could use the side, okay, if we were choosing, okay. Therefore, if then you know the other two sides are proportional. You do not know, however, whether that the scale factor is 2/3 as determined by RS over XY. Therefore, this is not sufficient information. Okay. Choice B, you know all the sides are proportional by the same scale factor, so this is sufficient information. So choice B. All right, check your progress. Go ahead and pause your video. Okay, which of the following would be sufficient information to prove the triangles are similar? Good. Now, if you said AC over DC, okay, equals the BC over EC, you are correct, because we also have then the vertical angle in the middle, so we could use a side angle side. All right, here we have properties of similarity. Reflexive property. Obviously, triangle ABC is similar to itself. Symmetric property basically says if two triangles are similar, then the reverse statement can be made by flipping the order. And then also transitive property. If two triangles are similar to a third triangle, then we could say that the first and the third triangle are similar. All right, how can we use this? It says we're going to try to find RQ and QT. Now we know if they are considered similar triangles, then we know that the sides should be proportional to each other. So we should be able to say that 4 is to 10 should be equal to the x plus 3 ratio compared to the 2x plus 10. And what can we do from here? I think we can cross multiply and get 10x plus 30 equals 8x plus 40. Subtract 8x from both sides and subtract 30 from both sides. And then divide by 2. It looks like we get x equals 5. Once we get x equals 5, we could put x equals 5 in here and get 8, and put x equals 5 in here and get 20.